Hello there. It's now time for another basic science lesson, and today we'll be looking at the topic sound. Now the objectives of this lesson is to help learners define sound and sound energy, to describe the characteristics of sound, describe the transmission of sound in solid, liquid and gaseous medium, to describe the reflection of sound and echo, and finally to describe how man can hear and interpret. Now, first and foremost, what is sound? Sound is a form of energy that can be heard and travels in waves. It is a vibration transmitted through a solid, liquid or gas. When the sound waves reach the human ear, the ear can then interpret the sound. Now, as you can see here, this picture shows that sound is vibration. Now, vibration is created when there is a force exerted on an object. That object will create vibration, which we hear as sound. Moving along, we'll be talking about the properties of sound. Now, the properties that we have is pitch or frequency, amplitude or loudness, speed, reflection of sound, timbre or quality of sound. Now, starting with pitch or frequency. The perception of frequency of sound by the human ear within the range of human hearing is called pitch. The higher the frequency of the sound, the higher is its pitch, and the lower frequency means the lower pitch. So in general, the pitch is the reason behind the difference in voice quality of different individuals. Now, amplitude or loudness. The amplitude of the sound waves determines its loudness. The amplitude of the sound is a measure of its magnitude of the maximum disturbance of sound. The amplitude is also a measure of the energy of vibration. The more energetic the vibration causes, the larger the amplitude. Now let's move ahead to the speed. The speed at which the sound wave travels through the medium is called the speed of sound. The speed of sound is different for different mediums. Sound travels faster in solids, since the atoms in a solid are closely packed together. Yes, the speed of sound is faster in solids, followed by liquids, then finally gases. Now, sound can be reflected. Reflection of sound. When sound waves hit the surface of a solid or liquid, it bounces back to the same medium. This is called the reflection of sound. Sound waves, like light waves, follow the law of reflection. Timbre or quality of sound. Timbre is the property used to differentiate sounds of the same frequency. Timbre depends on the material through which the sound is produced. Different materials produces different quality. Now, moving along, look at this picture right here. You can see that this picture explains pitch. Now you can see that the frequency talks about the amount of waves that is produced in 1 second. That is frequency. Now, as you can see here, that you have a higher frequency. Why? Because in 1 second you can see that you have like three up and down waves. As you can see, this is the second one. Now this is another cycle of wave. This is one cycle. This is another cycle of sound. This is another cycle of sound wave. So you have 3 cycles of sound waves at a particular time. So you can see that the higher the frequency, so you can see that you have 1, 2, 3. So the higher the frequency, the higher the pitch of sound. Here you have only one oscillation or one complete wave in the same time as you have these 3 complete wave here. So the frequency is low, and because the frequency is low, the pitch sound will be low. Now let's look at loudness. Now you can see amplitude talks about the maximum height of every wave. So you can see this is the height. This one explains the amplitude. This one also explains amplitude. So the highest height of a sound wave describes the amplitude. Now, as you can see here, that the higher the amplitude, the louder the sound that you hear. But here you can see that you have a lower amplitude, therefore you have a quieter sound. Now, moving along, we'll be looking at the production and transmission of sound. Sound waves can be produced by movement or action which causes molecules to vibrate. So if you hit, for instance, if you hit a table, or if you hit a metal or if you hit anything, it will produce what? Vibrations. It will produce vibration. So this vibration is what is transmitted across the various medium, whether solid, liquid or gas. Now sound travels in a straight path from its source. Sound cannot travel through a vacuum. Why can't it travel through a vacuum? Because there is no medium for transmission of sound in a vacuum. There are no particles or molecules in a vacuum. And because the vacuum does not contain any particle or molecule, sound cannot be transmitted. So sound waves can be transmitted or moves faster through liquids and solids than through gases. In fact, it moves fastest in solid, followed by liquid. Then lastly, it moves very slowly in gases. Now, as you can see in the picture that you have here, there is something that produces sound, a siren. A siren produces sound waves. Now this talks about an object that produces sound. So a siren produces what? Sound waves, and this sound waves vibrates through the air, or is transmitted or carried along through the air, and you can hear it with your ear. It can also be transmitted through water, because the vibration can also flow through water. But there's no sound in a vacuum, because in a vacuum like space, you cannot hear any sound because there are no particles to transmit sound. Now we'll be moving along to the reflection of sound. One of the properties of sound is reflection. So we are going to be looking at reflection of sounds. When sound reflects off a surface, it will bounce out in a straight line no matter where it originally hits. Reflection of sound is responsible for many interesting phenomena such as echo. Echoes are the sound of your own voice reflecting back to your ears. A sound wave will continue to bounce around the room until it has lost all its energy. Sound is a wave and is also a form of energy. Now, as you can see from this picture or diagram that we have here, now this is a producer of sound. This produces sound waves. Now, as sound waves moves through the air in a straight line and it hits an object, the sound is reflected back in the same direction that it came. The reflected wave in this case will be the echo, and that's why if you've ever been to a canyon or a mountain area, someone may shout and you hear the voice reflected back to him or her in tones. Maybe you can hear a sound like hey, then it will be reflected by hey, 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 and it goes like that. That is what we call echo. That is what we call echo, the sound of our voices reflecting back to us. You know, under the right conditions, you can actually hear the echo of your own voice. Okay, so now we'll be moving on to how we hear. How do we hear as human beings? Now, the human ear is able to feel frequencies between 20 Hz to 15,000 Hz, depending on the age of the person. Now, the human ear has three main sections, which consist of the outer ear, the middle ear, and the inner ear. Sound waves enter the outer ear and travel through the ear canal to the middle ear and inner ear, where the sound waves are processed. The auditory nerve transmits the sound waves to the brain, where the information is interpreted and distinguished from different types of sound. Now, this picture here clearly shows the description of how we hear. Now, first and foremost, sound wave will enter into the ear through the pinna into the ear canal. So you can see here that sound waves enter the outer ear and travels through the ear canal to the eardrum, striking the eardrum. Now, the second step of the process is that your eardrum vibrates with the incoming sound and send the vibration to three tiny bones in the middle ear, which are the malleus, incus, and the stapes. So these are the three ear ossicles. Now, in the third process, the bones in your middle ear amplify the sound vibrations and send them to your inner ear or cochlea. Now, this is the cochlea right here. The sound vibrations activate tiny ear cells in the inner ear, which in turn release neurochemical messengers. And finally, the auditory nerve carries these electrical signals to the brain, which translates it into a sound you can Okay, so now this brings us to the end of our lesson for today. Now let's take a quick look at the summary before we go. Sound is a form of energy that can be heard and travels in waves. Sound has properties such as reflection, frequency, amplitude, speed, and timbre. Sound waves can be produced by movement or action which causes molecules to vibrate. Sound waves move faster through liquids and solids than through gases. When sound reflects off a surface, it will bounce out in a straight line no matter where it originally hits. Sound waves enter the outer ear and travel through the ear canal to the middle ear and inner ear, where the sound waves are processed. So before you go, I want you to pause this video and go through the assessment that you have here to see how much of the lesson that you have imbibed. And I'll see you again in the next class. Bye.